This is Unit 4, review number 2 from day 9. We're doing numbers 8 through 11. So in these problems, 8 through 11, the directions say use the min-max existence theorem. All right, so use that to determine what your min and max actually are. So if you look at these problems, basically the idea is you're given a graph, and then that graph is broken up into a region. And number 8 is from -4 to -1. And I want to know what is the minimum and the maximum in that region. All right, so when I take a look at that, I first need to make sure that it is continuous. So I'm just going to do this for all these. Number 8 is polynomial, it is continuous. Number 9, sine function, is continuous wave function. 10 and 11 are also polynomials. So these all are going to have mins and maxes when I do this. So what do? When you do this, basically the idea is you can have your minimum and your maximum in really 3 different locations. One is at the start. One is at the end that it gives you, and then also at any turnaround point. So it would be mins and or maxes of the graph between the start and the end value. How do I find out where the mins and maxes or the turnaround points would be? Well, turnaround points, again, are just where the graph is at its minimum or at its maximum. So that would be when you take the derivative and set it equal to 0. So I have -2x minus 5. I set that equal to 0. And when I do so, I end up with x is equal to positive 2.5. 2.5 is not between, I'm sorry, it's equal to a -2.5. Let me correct myself there. It's equal to a -2.5. If it was a positive 2.5, it was not between this, and then I wouldn't have to worry about it. It is, however, in between -4 and -1, so therefore we have to look to see what is f of -4, what is f of -2.5, and what is f of -1. And how do I find them? The question is, where do I plug those in? It's really 2 spots, either the original or the derivative. And since I want f of that, I want the y value, it's got to be into the original. So you take -4 and you plug it in, and you get 11. You take -2.5 and you get 13.25. And you take -1 and plug it in, and you also get 11. So what does that tell me? That tells me that I have an absolute maximum right here at the -2.5, 13.25, so that's an absolute max. And I'm tied for the minimum, the lowest value, at the -4, 11 and -1, 11. So they are my absolute minimums in that section. All right, number 9, very similar. We're going to first take our derivative, so f prime of x here is going to equal to 4 times by cosine of x. 3 goes away. We're going to take that, we're going to set that equal to 0. So it's really divide by 4. You're really looking to see where's cosine of x equal to 0. So cosine of x is equal to 0. I always like to look at my graph. When you look at your graph, here's your graph of cosine. Cosine is equal to 0 in 2 spots, right there and right there. So this first one is at pi over 2. The next one is at 3 pi over 2. Remember, 0, pi over 2, pi, 3 pi over 2, 2 pi. All right, so those two x values, x equals pi over 2 and 3 pi over 2, I need to decide, are they in my region? And if they are, then I need to account for them. If they are not, then I do not. All right, so when I first go through and look at this here, I'm going to have my f of 2. I'm going to have my f of 4, and like I said, any other numbers that are between there. So pi over 2, pi divided by 2 here is going to be 1.57. So that is not between my 2 values there, so we don't need to worry about that. All right, whereas the 3 pi over 2 is between those 2 values. So I am going to have to go through and look for those. Okay, so we have pi over 2 and we have 3 pi over 2. So we need to decide whether or not those are going to be between our 2 and our 4. So how do you do that? So pi over 2, and you take that on the calculator. That's pi divided by 2 is 1.571. I said that earlier. 3 pi over 2 here is going to give you a number bigger than 4. So what does that tell me? Well, that just tells me that there are not any values between those 2 that I have to worry about. So there's no mins or maxes there. So between 2 and 4, one of those has to be the minimum, one of those has to be the maximum. So the 2, I take it and I plug it into my original, and I get 6.637. And I take 4 and plug it into my original, and I get -0.027. So I'm trying to figure out which one is the minimum, which one is the maximum. This is my absolute max. and this is my absolute min. All right, we'll do the same exact thing for number 10 and 11 now. So for number 10 here, I'm going to take my derivative. F prime of x is going to equal to 3x squared minus 2x minus 2. Again, I'm setting that equal to 0 to find any mins and maxes. All right, and I'm doing that so that I can find out if there are any mins and maxes that occur between -1 and 2.5. So when I do that, I set this equal to 0. I end up with really two answers here. I get x is equal to a negative 0.549. And again, you can do this on the calculator.
Just a reminder, the girls' soccer team will be returning their uniforms today. Also, driver's ed is in room C205. Again, the girls' soccer team will be returning their uniforms today. Driver's ed is in room C205.
Okay, apologies for that. That's the second interruption we had. We'll try this again. So when we're doing this, again, if you put this into y1, put this into y2, you can find out where these two intersection points are on the calculator. I need to know, are those two between here? They both are. If there's only one, then I would only choose the one, but they both are between. They're in my bounded region, so I'm going to find out what they are. So again, I take these and I plug these into the original. And when I do so, when I plug in my -1, I get, I actually don't have that in front of me. I have my negative 0.549 is 0.631. My 1.125 is negative 2.113. And you take 2.5 and plug that in, and I have that as 4.375. Okay, so the -1, we can figure that out right now. For whatever reason, I did not have that. -1 to the third there, that's just going to be -1. -1, -1 squared is going to be a +1, but that negative keeps it as a -1, and it's going to be a +2. So it looks like that's going to come out to be a 0. All right, so now I need to find my minimum and my maximum. Looks like my maximum here is going to be my 4.375, so that's my absolute maximum. And then my absolute minimum is going to be this negative, so this is going to be my absolute minimum. All right, one more. So this one looks a little bit easier. We're going to take our derivative. Again, you always take your derivative. This is going to be 2x minus 2. You set that equal to 0. Solving it, x is equal to 1. So you have to try to figure out, is 1 in my bounded region? It's not. We only care about from 2 to 4. So I really only need to find f of 2 and f of 4. So you take the 2 and the 4, plug it into your original. 2 gives you a -5, and 4 gives you a +3, which means that the -5 here is going to be my absolute minimum, and my +3 is my absolute maximum. Right?